Programmable Logic Controller, or PLC, is a specialized computer used to control processes in various industries, such as automotive manufacturing, food processing, and pharmaceutical manufacturing. The purpose of using a PLC is to automate manual tasks, which promotes efficiency and productivity. By utilizing PLCs, industries can streamline operations, reduce human errors, and improve overall product quality. PLCs are highly effective in managing operations that involve high-speed counting, precise timing, and accurate positioning control for applications such as packaging machines and conveyor systems. The functions of a PLC include ensuring safety protocols for equipment and personnel in industrial settings, performing data logging and analysis, which helps industries monitor production metrics, detect bottlenecks, and optimize processes over time, and enabling hot swapping of inputs or outputs, which facilitates maintenance and upgrades without shutting down the entire system. Hot swapping is the physical addition or removal of PLC modules while the system is operating. For example, in a production unit, a set of machines operate during the day, such as a day motor, and another set of machines operate during the night, such as a night motor. PLCs enable dynamic switching between these two sets of machines without downtime. PLCs continuously monitor input signals from input devices, such as sensors and switches, through an input module. Based on these input signals, the PLC makes real-time decisions and sends output signals through an output module to control output devices such as motors and valves. PLCs offer the advantage of simple reprogramming and modification, providing flexibility to adapt to changing production requirements. Unlike manual control or standard computer control, PLCs are designed to operate continuously for years without the need for reboots, ensuring reliability for industrial operations.